Hey everybody, how are you? All good? Okay, fantastic. So I will talk a bit about how to build continuous security. So I will catch up on a couple of topics that the other speakers were talking about. So you will see a couple of similarities in there. I usually start with an experiment. Do you want to know how security feels like? So just really feel it, because it's a very intangible topic, so no one knows what security is about. Do you want to feel it? Okay, good. So put out your phone. It's really a super simple thing. For those who did it, give it to your neighbor. Doesn't feel good, does it? No, it doesn't feel good. So, but that's, if you want to make someone aware how security feels like. So if you ever are in a position to talk to your board, to your CEO or something, tell him, give me your phone. He won't give it to you. He will feel so uncomfortable with it. And then you can say, ah, there it is. Even with a secure iPhone or any other phone, you don't feel secure at all. So just as a little trick, that's how security feels like. It's scary. You can't even give it away. In another conference, I had to give it away, and we exchanged it back at the end. It really felt very bad. But the good thing was no one was distracted, because you couldn't type anything in between. So all the QR codes I use are safe. You can use them. You can also have the slides. So this is just the LinkedIn link. So if you want to connect with me, you can have the slides afterwards, or you can use some stats that I use here. So who am I? I'm Andy Schneider. Originally, I'm from Munich, but I left Germany about 13 years ago. And I'm in security now for over 23 years. That's why I lost all my hair. And I started in a bank. Who's in a bank? Super boring. I think it's the same today. Working in a bank is super boring, but I learned a lot about security. So I directly started in security and stayed in there. And the last 10 years, I've been CISO, so the security leader of different companies in Switzerland. So I moved to Switzerland. Digital companies, so everything, cloud security, everything, DevSecOps, AppSec. So I built these teams. Really enjoyed it. And around 1 year ago, I joined a vendor. So I joined to the dark side. That's Lacework. So we offer a cloud security platform. But nevertheless, I'm still feel like an evangelist how to build DevSecOps, because there are many myths around it. DevSecOps, AppSec, how to do that. I did that. I did many errors in the past. So I'm always glad if I can share my experience how to do that. So it's not a Lacework pitch. Lacework is somewhere in there, but it's more about how to build DevSecOps or modern security. So if we think about some principles, build continuous security. Do you believe that security people are good in building? Number one, security is not good in building. Developers are. So my first advice to anybody in security who is not developer, talk to your developers. They're way better in building. Challenge a developer with a problem, and he will find a way to solve it. That's what developers love. Security people don't like that. They don't like problems. So it's better to work together with the developers, or let them come to the solution. They're really bad at that. Do you know why I used that puppy photo? It's a random statistic, but it's really scary. 85% of people posting a puppy photo are trying to scam you. That's really just, that's super random, but I found it and I thought, okay, doesn't have to do anything with it, but statistics can help you. So be aware. So I did a puppy photo. I don't want to scam you. And the next time you see one, I guess it's someone that wants to scam you. So second, we talked about building. So developers are good in building. What does continuous mean? Well, continuous, doing things continuously means that you do that at the speed of development. And development is at the speed of the business. So developers are much closer to the business because they deliver the features, the functionalities that bring money to the company. It's not security. So if you want to be successful in security, in AppSec, you have to do things at speed of development. In my last company, we had like plenty of digital subsidiaries, like independent companies. And for example, one was there, they deployed every 2 minutes. Everything was running on AWS serverless, so really a serverless only architecture. Everything was in 2 minutes. So the production changed every 2 minutes. So when I, as a security, come and say, I'll do a monthly pen test, that's like so shitty slow. You can forget it. That's not working. So you have to do that at the speed of the business. And that's very different on which tech stack you are and everything else. The next thing is, if you want to be at the speed of development, you have to embed things into development, not the way around. So if you have a security team that tells you you have to use tool ABC and go to that console, kick in their ass. That's the wrong way. They won't succeed with it. They have to deliver security that embed and integrate into your tools if you're a developer. If you're a security, integrate in the development tools. That's important. So Excel and PDF, they don't exist. Never, ever. You can write a rule. You can write a rule in your inbox. Attachment, PDF, spam. Remove that. There are way better ways. And so I think most use tools like Jira, Slack. Anyone using Teams? Oh my goodness. Do you use that because you like it or you have to? Okay, good. So I hate Teams. Okay. So, but the important part is, as a security team, you have to deliver context. So if you just put in a random vulnerability in a ticket, this doesn't help you. You have to provide context. That's really essential. I will explain what context means later. So now there's the magic trick. Who knows that guy? Anybody doesn't know him? It's Thanos, for those who are afraid, raising their hand. Snipping away 50% of the galaxies or universe's population. But there is a trick how you can remove almost 50% of your security problems. First, remove Microsoft. Removing Microsoft will actually remove a lot of problems for you. But besides that, who's developing in Rust? No one. Who's developing? Oh, yeah, a little bit. So everyone should do like that to you. Who's developing in JavaScript? Oh dear. Okay. If you look at statistics, so I ran a couple of bug bounty programs. So we had super scaling media platform, one based, everything based, AWS, EKS, super scaling, fancy shit. The one mostly used Golang, the other one used JavaScript. The one with JavaScript just cost us around $100,000 more in bug bounty than the one in Golang. Actually, Golang is a more secure language. If you go to Rust, it's, I would say, one of the most secure languages. I wouldn't say that it's intended to do like front end and other things like that. But if you involve security super early, not just at the end, but at the early beginning, before you even start developing and hiring, you might do some choices. So my last company, they asked, okay, what do you think? Should we go with Microsoft or Google? And I said, go with Google. So we went with Google Workspace, and Microsoft disappeared. Phishing didn't work anymore. Macros didn't work anymore. PowerShell didn't work anymore. And the same applies to coding languages. So involve security very early. But as a security person, you have to understand coding languages and what impact security has in there. Because if you have a more secure language later on, you don't have to invest so much in security. That's a reality. Second thing, hire good developers. Invest in developers. If you have the best developers, they will write good code. Also in JavaScript, you can write good code. And with that, you have less problems. So security is not the solution to do security, it's your developers. Okay, didn't talk much about DevSecOps yet, so stay focused. I know it's the afternoon. How does DevSecOps look like? There is no official framework. But this is like a blueprint how I've set up DevSecOps in different teams. It's more than AppSec. It's more like a framework that has some shift left elements in it and shield right. So if we go to the left, your infrastructure, if you are in the cloud, should be code. If you are in the cloud and your infrastructure is not code, that's the first thing you should do. Never, ever touch, let's say, an operating system in runtime. This is like evil. You should not do that. You should have everything as code. Your application is code, the same your infrastructure is code. That's like a rule. Because if you have everything as code, you can avoid problems on the very left side. So that's the shift left. If you still do things manually, you will fail. At a certain point, you will fail. Everyone fails. I did so many failures. Mostly I did them if I did things in runtime and not in the code. Because from a security perspective, every code change usually should be, for example, a pull request. You can formalize 4i principles and other things that have been there in security for decades and where security always struggled to really enforce that. Threat modeling. In the last, I heard the panel, I think it was like 2 hours ago, the panel here, about vulnerability. So I will talk a bit about threat modeling because it's an excellent exercise. If you use your brain before you do things, it's really very powerful. So, and that's what threat modeling is about. You think about what might go wrong. If you go outside and you see, oh, there are dark clouds out there, maybe I need an umbrella. That's what we humans do. So don't just code, think about what might go wrong. That's what threat modeling more or less is about. I will deep dive a bit. From there on, if you have written your good code, because you're a good developer, not using Microsoft, developing in Rust, so it goes to your pipeline. Somewhere, your automation starts. You can check your infrastructure code. These are like infrastructure as code scanners, open source, commercial, I don't care. And then you can go up the layers to application code, that's SaaS scanning. There you do the same. You try to find flaws. But obviously, as you're a good developer, it passes all that. So you won't have vulnerabilities in there, or only lower ones. Once it's in production, you can do so many things. Who is doing dust scanning, like vulnerability scanning? A few. So actually, this is a more old-fashioned way of finding vulnerabilities. Usually, you don't have much context with DAS scanners. So if you take the report from the DAS scanners and give that back to the developers, they sometimes appreciate the report, usually they don't, because it's a lot of noise. But actually, that's a way of scanning from the outside. Bug bounty programs, on the other hand, I love bug bounty programs, because humans are more, I would say, still smarter than tools to find flaws. So this is an excellent way. If you have Java script, haven't done anything in the middle, don't start a bug bounty program. It might really blow up your budget. So I've seen that. There are languages that are even worse. So I remember a legacy application written in .NET. Whoever invented .NET, but it was written in .NET, and we had to stop it after 1 hour because we were like paying almost $100,000 in 1 hour because it was just a piece of mess. So they had to rewrite everything. That's, by the way, a good example why it's good to involve security earlier than later. Then there are things like more on the infrastructure layer. You can do cloud vulnerability management. That's like the infrastructure. Posture management. That's the configuration of your cloud environment. You can find secrets in there. So that's, by the way, something still one of the most obvious findings. So API keys, for example, AWS API keys, that's like a common one that you might get reported by AWS if you have an enterprise contract or from the other hyperscalers. And then you have to somehow find a way to revoke the keys, make everything running again. So you have to be prepared for these kinds of incidents. KIEM, it's like the worst name ever. It's pronounced KIEM. So it's not pronounced SIEM. SIEM is something else. Whoever invented that, I don't know, but it's KIEM. It finds you toxic combinations. So you might have like a role with an assumed role, getting access to something. So these combinations can be really dangerous in a cloud environment. And then there is UEBA, CWPP, and DDoS protection. I'll come to that later. Who has ever faced a DDoS attack? A few. So the others haven't. You will. So if you don't have DDoS protection, you should have. It's not expensive. You might even get it for free, but never skip DDoS protection. So now let's go to threat modeling. The most left side. I'll deep dive on a few topics, not all of them. Threat modeling is a very good exercise, and it was mentioned before. There's, for example, the Stride model. Microsoft invented that. That's a surprise, but it comes from Microsoft. But there are other models like Stride. The idea is you think about what might go wrong in a couple of like types. So can someone tamper in there? Can someone do a denial of service, elevate privileges? So thinking about these kind of things very early can really help you. There are like checklists available with questions that you can use in some kind of sessions where you think about your feature that you develop, what might go wrong. You can go further. So as, for example, chaos engineering, that is more or less the same idea. You do some exercises where you think about what happens if someone randomly does inputs, or what happens if I increase latency between the connections. How does my application react to that? So you can really master that, but I recommend looking at that. This is really super powerful because you can avoid problems very early. And you do that not alone, but in your team and discuss what might go wrong, because others are usually better than someone alone. Now, I always struggled a bit doing that with developers, so to formalize that. What I recommend is trying to use the elements in the threat modeling that might really be relevant for your application, for your environment, and then define that as security stories. Or I even like it more, it's abuse stories. The problem is, if you now go to Google and look for abuse stories, you find different things. So you can also use for misuse stories. You might find them better with that. So I'll follow that QR code. So there is like a good list of the Stride model, and from there on you will also find misuse stories. But you write it from a hacker's perspective. So I want to do random inputs, for example, to do something. So in this example, it's a typical thing with malicious redirects. That's what your dust scanner finds. That's what your, for example, also your SAST scanner might find. You can define that as a story, put that in a default Kanban board for everything that is being developed, so that the developers look at that and move that to done. That's a simple technique. Another statistic, because we talk a lot about shift left, that's code. You go to the left. But actually, that's a report from Mandiant. So Mandiant is a famous security company bought by Google last year. And only 26% of attacks against companies are detected by the internal teams. Internal teams means security or developers. So it's externals that find that out. So your customers, that's brilliant if your customers find that out, or the government, that's even worse, depending what software you develop. So you don't want to end up being in that, let's say, 74%. You want to be in the 26%. And that's an issue. If you only focus on shift left, this will not detect anything. Imagine who has kids? Many. I have them as well. Do they clean up their room? No way. No one does that. My wife tells me, even I don't do that. So, kids don't clean up their room. If you do all the shift left, it's like removing all that stuff from the room. And shit happens next day, the same shit is lying around. So you have to remove that again. That's all that shift left. You can automate that. You can try to be more efficient, trick your kids. But in the end, if a fire breaks out, that doesn't help you. You need a fire sensor somewhere. That's what people often forget. And a fire sensor, you only need it once in a lifetime. But then it detects something. So detection is very difficult. You don't need it very often, but it really saves your ass. So, but why do people don't like detection? Detection usually means you have to put some kind of agent technology. If it's, for example, in a container, you have to put an agent in there. Who likes agents? Oh, one. Brilliant. So, I argue that very often because agents are complicated. You have to somehow deploy them. They might cause issues. So let's just not use agents. But it's really difficult to get context without agent and to do detection without agents. It's only partly possible. So where are agents good? Okay, I'm biased. My company has an agent, but there are many others that have that as well that are also good. Agents deliver runtime context, and I explain why that is important. Think about vulnerability scanning. Everyone hates it, but I make an example. I have my laptop, I have Firefox and Chrome installed. So Firefox has, I don't know, 100 critical vulnerabilities, but I never use it. And my Chrome browser has one medium vulnerability. Which one should I fix? I use Chrome all the time. All of them? Which one should I fix first? Exactly. Because that's the one I use. That's the one that can be exploited. Someone has to access my computer to then exploit more things with the Firefox one. That context you only have on your host. So if you have, for example, vulnerability management or SCA scanning, the libraries you use. So you might put in there OpenSSL as a library somewhere, and then you forget about using it. You don't ever touch it again, but you don't remove that include statement. So every random scanner will tell you, fix that OpenSSL vulnerability. But if you are not using it, it's not important to fix it. If you have an agent installed, it can tell you that has never been touched. It's okay to fix it, but you should fix other things first. So that's where runtime context is important. And you don't have to use a commercial scanner. You can do things with open source tools to think about how can I, as a security team, provide context to make vulnerabilities actionable. So that's a really rare example, but I found one in one of our systems where we had around 300 CVEs in there. But actually, there is only one that has to be fixed. So if you think about developers, they hate all that 300 things that are not actionable. They have to be actionable. Even if there is, for example, if there is no patch available, it's good to know. that is not actionable. You have to provide that context as a security team. That's hard, but then from a development perspective, you can do it right. So that's really essential. I have to speed up. All the middle part layers, that's CNAP, that's a category. We have a tool for that. You can talk with me or without me about that. I did a strike through for dust. If you scan from the inside, and if you run a bug bounty program, I personally don't see much value in a dust scanner. Usually, you get rid of the little low noise, low vulnerabilities very quickly. And in a bug bounty program and the other ways, it's much more efficient doing things. So that's where I would save money. But that's no longer looking that complicated, the whole cycle. So we are almost through it. We are making it through it. Now, if you think about vulnerabilities, I heard also in the last talks a lot about training. Who did an OWASP top 10 training in the company? A few. Did you really like it? So the reason I did a couple of OWASP top 10 trainings, I held trainings as a trainer and as a trainee. And actually, I found out mostly the trainings are not relevant. So I actually had teams developing in Rust and Ruby, and we did fantastic with JavaScript and cross-site scripting. And then they said, well, it's good, but we use Ruby. I thought, OK. And then the next team used Golang. The next team used something else. Making a training relevant is really difficult. That's a key. So one tip I have is take from your vulnerabilities that you collect, from SaaS scanning, infrastructure as code scanning, from your cloud vulnerabilities, from the bug bounty programs, if you still have a dust scanner from that, take that and look, what vulnerabilities do we find? There is, so Bugcrowd is a managed bug bounty platform, but they have a good vulnerability rating taxonomy. So you can find out where do we have vulnerabilities. So by the way, that's a very typical setup. Mostly you will have server security misconfigurations that you find. That's the cheap ones that the hackers earn a lot of money with. Cross-site scripting, SQL injection, redirects, these are the typical things. But take the top 3 and make the training in the language based on those top 3. That's relevant for your developers. You can show it to them. This is what we find in our platforms. And then they will train on that. So now that's a very good metric. You can measure that later on. Is that changing? Are we getting better with, for example, server misconfigurations? You can measure that with bug bounty programs or with the statistics you have, if you have it in the right tools, of course. So I would always put everything into Jira, and from there on, you can make a lot of statistics. Then you can easily measure that and measure if you're improving your security in there. There are other metrics that are really good, but what I would do is take those, create again security stories, abuse stories, and then make a specific training out of that. There are tools that are doing that automatically for you, and you have a full automated cycle. And you can also feed your threat modeling. If you know we are really bad in cross-site scripting, include that in your threat modeling. Focus on that, leave out the others. So you can really maybe focus only on 3 elements in the stride model instead of all of them, if you know that's where we are not good. Or hire better developers. That's also a way to do that. But I would always try to skill that up and then start measuring. So if you start measuring, there are some bad metrics and good metrics. So bad metrics are amount of vulnerabilities. If your business is growing, you started with 1,000 lines of code, now you have 10 million, yeah, of course you have more vulnerabilities. It doesn't say anything. So you have to look what is really relevant for me. From a security team's perspective, it might be relevant, the mean time to fix something. So how long does it take us from detecting it until we have a fix applied? So getting that down, for example, from 100 days to 70 to 50 to 20, whatever. If you look at vulnerabilities, it's more complicated, but you could say vulnerabilities per line of code over time. That's a good one. No one is providing you that number, you have to calculate that, but then you know if you're getting better a little bit. And if you run bug bounty programs, you can see statistics, how long does it take until you accept the vulnerability? That's also a very good ratio to see, are we getting better? So is security part of our development of DevOps? That's an indicator that you have achieved DevSecOps. Okay, that's almost it, almost through it. So my personal key learnings, I did it a couple of times. Shift left doesn't mean that you do it in the code. It starts with your developers and with the idea. So even earlier. So using the right language is where there you can save a lot. And the right infrastructure, so the right tools, collaboration tools, Microsoft, these things, there you can really save a lot of security. Using security stories instead of policies. Everyone hates policies, so if you still have an intranet and there is a security policy in there, try to hack it and delete it. It should be somewhere else in security stories in your Jira or somewhere else. Integration automation, threat modeling, code checks. You don't have to do everything, by the way. It's really more a journey, maturity journey. But I've seen teams really doing everything. DDoS protection. So when my second son was born and he was 1 month old, we suffered during the pandemic, a 1-month DDoS attack. So I was almost dead after that time because it was really a DDoS attack. It changed patterns like 24 hours every day for 1 month. So I was done afterwards. DDoS protection gives you time back with your kids. So I really recommend that. Detection. Never forget detection. There's a good, some call it shift left and shield right, but never forget the right side. There is more about security, not just the left side. Do data-driven decisions. Everything. Also security, modern security is data-driven. It's not like you need policies or something. You need to make decisions based on data and statistics and measure it. Because there will be the time where suddenly a war breaks out, there is not enough money, and then they will ask you, is that worth spending money for security? So having measurement points for a longer time is really worth it. And as we are at the end, so I have no slide with thank you. I keep that slide here. Some further reading, if you like it. There are not only the big bug bounty platforms, there are also smaller ones, more local ones. There's one I like, it's a Swiss one, Go Bug Free. You can talk with me about Lacework another time. Then also, I think it was in the panel about how to bring in security very early. So if you, who's building enterprise software, by the way? So if you leave out security in enterprise software, you're done. So, honestly, in enterprise software, you have to have security because you become like a third party for the enterprise companies, and they look for security. A good way to tackle that is the minimal viable secure product. Google was more or less the one starting it. There are like baselines in there that many companies use. They will check that with you. Check that, then you are more or less on a secure side. By the way, who is in a startup? Also a couple of them. So I'm also working with a VC, and I do due diligence. And I look at the company's security, and if there is no security in there, we don't invest. Because we know we have to invest maybe 100,000 or 200,000 additionally to clean up the mess. And that lowers your valuation from a VC's perspective. So security is essential. Then there is, it's more old, but We Hack Purple. There is a Pushing Left Like a Boss series. It's worth reading that, like 9 blog posts about how to shift left and push left. It's a fantastic read. And I always recommend the SRE book. Who has read the SRE book? Come on, you have to read that. It's like the SRE book it's all about site reliability engineering, but the focus of that is automation and avoid toil. So toil is noise, how to bring context, making it actionable. That's a good read. And if you are more in a leadership position, I recommend Turn the Ship Around from David Marquis. It's about intent-based leadership that's more or less agile in a nuclear submarine. That's a fantastic read. So it's really mind-blowing, because if someone tells you that's not possible in our company, if you read the book, you can tell him it's possible in a nuclear submarine. So it's also possible in our little enterprise. So it's worth reading that. And with that, happy to answer any questions, and maybe we keep in contact. I'll be here a little bit afterwards, but you can also connect with me on LinkedIn, and I'm happy to get some questions. Thanks.